So in 86 volts, a life was lost. It's hard to believe, but even low voltage electricity can be deadly under the wrong conditions. Let me share a story. An employee was performing what seems like a routine task, changing a welding rod inside a confined metal sleeve. But in an environment like this, even small voltage can have catastrophic results. A tragic electric shock led to his death because the right safety system weren't in place. Now imagine transforming from workplace where these risks are constantly present to one where electrical safety is a top priority, where every risk is assessed and controlled and every life is protected. From avoiding low voltage fatalities to preventing a dangerous mistakes during routine tasks, this video will equip you with the knowledge and tools to ensure electrical safety in your workplace. Hello health and safety professionals, welcome to Occupational Safety. I'm Roshan Rajas and I bring over 15 years of experience in the field of occupational health and safety. I'm a certified safety professional, a Canadian registered safety professional, a chartered member of IOSH, and qualified trainer and assessor. Here on this channel, we simplify complex safety topics into practical, easy to follow steps, all designed to help you build a safer, healthier workplace. Whether you are a seasoned professional or just getting started, our goal is simple: to give you the tools, tips, and real world knowledge you need to protect people and prevent harm. And if you are preparing for your NEBOSH, IOSH, CSP or CRSP exams, you are in the right place. These videos are built to support your success. So in today's video, we are diving deep into electrical safety, a critical topic that can save lives in high-risk environments like construction, manufacturing, and welding. First, we will start with an introduction to electrical safety, where we will discuss why electrical hazards are so dangerous and how common they are in the workplace. Next, we will explain the basic principle of electricity, breaking down the key terms like voltage, current, and resistance, and the crucial concepts of grounding and insulation. We'll then move on to the common electrical hazards you need to watch out for, from shocks and burns to arc flashes and fatal injuries caused by electrocutions. After that, we will discuss the electrical safety standards and regulations like OSHA, NFPA 70E and IEC, ensuring you are fully compliant in your workplace. Then we'll guide you step by step through lockout tagout procedures for electrical equipment, showing how lockout tagout can prevent accidents and saves lives. We'll also explore the personal protective equipment you need to work safely around electricity, from insulated gloves to specialized clothing and tools. And finally, we will walk you through how to conduct a proper electrical risk assessment and follow safe work practices to minimize risk. And to wrap up it all, we have got a quick fire section where we'll answer your most frequently asked questions about electrical safety. So stick around till the end, you don't want to miss it. Alright, let's start with some basic first. Before we dive into electrical hazards and safety rules, let's take few minutes to make sure we understand the basics of how electricity works. Because when you understand it, you respect it. Now think of electricity like water in pipes, right? Let's pull this the pipe, right? So voltage is like water pressure. It's what pushes the electricity through the wire. So voltage pushes the electricity like a water in a pipe, right? Current is the actual flow, like how much water is moving, right? So this is, or yes, this is the current. How much water is flowing through the pipe, right? Now resistance is anything that slows it down, right? So you can say whatever, because if the pipe has, if there is a friction and all that coming from this pipe, that could act as a resistance. So you might know the formula, we call it as V is equal to I into R, right? Voltage is equal to current into resistance. So yeah, this is something basic that we should know. The more voltage, the more pressure, the more resistance, the harder it is for the current to move. That's why damaged wires, weight hands or metal tools can be so dangerous. They change how electricity flows. Imagine you are holding a hose. The pressure, voltage builds behind the water. If the hose is narrow, less water current comes out, but if it bursts, water goes everywhere. Same with electricity. If insulation fails or grounding isn't there, the current can go somewhere dangerous, like through you. And this is why grounding matters. It gives electricity safe way out into the earth instead through someone's body. And insulation, that's like wrapping that hose in rubber. It keeps the electricity contained so it can't escape and hurt someone. So in some simple terms, voltage is a pressure, current is a flow, and resistance slow it down, like we saw in the diagram, right? So grounding gives electricity a safe exit, and insulation keeps it in its lane. Get this basic right and you have already eliminated that half of the risk. We will show you how to apply this in real life electricity safety later in the video. Now let's talk about common electrical hazard. So now some of the common electrical hazard you will encounter in the workplace. This is where the case study I mentioned earlier comes into play. In our case study, we had an incident where an employee was fatally shocked while changing an electrode during welding work. So this incident occurred due to faulty procedures in a metal silo where the worker was exposed to voltage of 86 volt AC while changing the welding rod. Even though 86 volts may not sound like much, it can be deadly, especially when the individual is trapped in a situation where they cannot easily escape the electrical current. Now imagine you are working in a similar environment. A good first step would be to implement strict hazard identification and risk assessments. You'll want to identify any exposed wire, ensure that machinery is isolated from electrical hazards, and check grounding and insulation regularly. So what is lockout tagout procedure, right? So let's understand now about lockout tagout procedure, which are vital for preventing electrical accidents when working on machineries. So in simple terms, lockout tagout ensures that machinery is safely powered down before repairs or maintenance. The procedure involves isolate the energy source, lock it out, tag it out, and test it. This is critical to protect workers from accidental electrical shock while working on machinery. So let's look at the lockout tagout procedure, right? So in lockout tagout procedure, the first step is to isolate. So here we isolate the energy source. After that, in second step, we lock it out. In third step, we tag it, right? In fourth step, we test the equipment. So it is also called as log out, tag out, and test out, right? To make it simplified. Yeah, this is how. So first, you isolate the energy source by shutting off the equipment and disconnect it from its power source. Then in second step, we do lock it out, where we use a lock to prevent anyone from accidentally turning the equipment back on. Then we tag it in the third step, where we place a tag indicating who is performing the work and the time frame and some other details for completion. In the fourth step, test the equipment. Once locked and tagged out, we always check that no energy is left in the system before starting work. Now I know lockout tagout procedures might seem like lots of steps in small amount of time, but they are crucial for ensuring the safety of workers around electrical system, right? But don't worry, we have created separate video on lockout tagout where I go into much more detail about how to implement LOTO correctly and the common mistake you should avoid. So do have a look at it. Then let's look at the PPEs for electrical work. You should use this PPE when working around electricity, because when you're working around electrical system, you'll need items like insulated gloves, rubber boots, and arc flash suits, because arc flash suits are critical for those working in areas where high voltage or electrical arc flashes could occur. This suit protects against extreme temperatures and flash burns. And to ensure safety, always do a PPE assessment based on the environment and the voltage level you are working with. Keep in mind that PPE must be regularly maintained and replaced after a certain amount of use to ensure maximum protection. Now let's look at conducting electrical risk assessment. So conducting a thorough electrical risk assessment is also important, and this could help in identifying potential electrical hazards and establish a control measure to prevent accidents. And these are the steps that are required for electrical risk assessment. These are same as a general risk assessment, where the first step is of identifying hazard, but here we are looking at electrical. So identifying electrical hazard, we are being specific, right? Where we review the site for exposed wiring, faulty equipment, and other risks. We can also discuss with other members who are working on those machines and all that, where we get more electrical hazard. After that, we understand who might get harm. And in stage 3, we evaluate the risk and implement control measure, where we assess the level of dangers posed by each hazard based on its voltage and environment. And based on your evaluation, apply proper or appropriate controls like logout, tagout, PPEs, and signages. After that, stage number 4 is of record your findings, and in the last step, we review and monitor, where we ensure that the risk assessment is regularly reviewed, and if any update is required, it is updated. You can watch our separate video on risk assessment for detailed information on how to conduct risk assessment. By following these steps and maintaining a strong electrical safety protocol, you can significantly reduce risk of accidents and keep everyone safe in your workplace. So by now you should have solid understanding of some basics of electrical safety and the common hazards and the best practices you can apply immediately in your workplace. Remember, electrical accidents can be prevented with the right knowledge, procedures, and equipment. Alright, it's time for our quickfire section, where we tackle some of the toughest but most important questions about electrical safety that you might be wondering about. Let's jump straight into it. So what should you do if your car hits an electrical pole? If your car hits an electrical pole, do not exit the vehicle unless absolutely necessary. Here's what you should do, or what you should consider. Staying inside the car, the vehicle might still be live due to contact with power lines or the poles, so exiting could expose you to high risk of electrical shock. And the second important thing is calling in emergency services immediately, right? Notify them about the incident and tell them that where you are located, exact location is important, and they will be able to guide you on next steps and dispatch appropriate help, right? You can also warn others to stay away. Keep people at least 30 feet away from the car. Electricity can travel through the ground as well, and anyone who steps too close to the vehicle may be at risk. And then you can wait for emergency responder. Only exit the vehicle once the professionals arrive and confirm that it is safe. They are equipped to handle the situation properly. So how can you tell if an electrical system is safe to work on? So before starting any electrical work, the first step is always to perform a risk assessment. If you check for potential hazards such as exposed wiring, damaged equipment, or any weight conditions, then it's become easier. So ensure proper lockout tagout procedures are in place. If you check that also would help. And additionally, use of an appropriate voltage tester to verify the system is de-energized, and always follow manufacturer's guideline and work under certified plans. Just like in the case study we saw earlier with the welding rod incident, risk assessment save lives. So are electrical inspections mandatory for all types of electrical installation? Yes, these are mandatory according to regulation like Health and Safety at Work Act 1974 in UK, or the Electricity at Work regulation. Depend on different part of the world you are in, you have to check the legal requirements for that particular area, and that way you can ensure that all systems are in proper working order and minimize the risk of electrical accident. So this is especially critical in high risk environment like construction sites and industrial plants where electrical hazards are common. So how do we prevent electrical fire? Preventing electrical fire starts with proper maintenance and inspection of wiring and equipment, right? Never overload circuits, ensure that cables and cords are good condition and avoid using damaged plugs. Make sure that all the electrical systems are grounded and properly installed. Like the tragic case from earlier, improper maintenance or damaged electrical equipment can lead into a fatal accident. And one important step is also knowing how to correctly identify and classify fire types and understanding the best method for extinguishing them. So we have already created a separate video specially covering this fire classification and how to properly extinguish electrical fire. So be sure to check that out for a deeper dive into fire safety. Regular checks, employee training, and using fire safety equipment are all key to preventing electrical fires. If you found this video helpful, don't forget to subscribe to the channel for more safety tips and expert advice. Drop a comment below if you have any questions or thoughts on the electrical safety, and feel free to share this video with your colleagues and friends. Safety knowledge saves lives. Also, if you're looking for more in-depth information on fire safety, be sure to check out our dedicated video on fire classification and extinguishing electrical fires. You'll find the link below in the description box. Thanks for watching. I'll see you in the next video. Until then, stay safe.